Okay, so yeah, you are right. Welcome back to Rocket Can, my fellow space tubers. So my mic actually glitched out, and that's why you weren't able to hear me. But here I am with you, and today we will be seeing the launch of this spacecraft, which is a Cygnus spacecraft, and it is a very beautiful one. I personally like it a lot. Lot means you just can see how does this look like, and yeah, I just look like I just uh, you can say it is one of my favorite spacecraft. So we will have the launch of this one from the NASA's Wallops facility, and the rocket which it will be carried upon will be the Antares rocket. So we will be going on each and everything which you need to know, as in what is going on in the mission, what is going to the ISS, and what it actually has. And yeah, let's just get into it. So first of all, how are you guys? Hi, SpaceX KSP, Washtag. Hi, James. Hi, John Wilson. Hi, Space Boy. Hi, Monarch Aerospace. Yes, I do remember you, Monarch Aerospace. And okay, so now we can have a look at this Cygnus spacecraft. So Cygnus spacecraft is a very you can say old one, being supply. It is like supplying space cargo to the space station, but since 2013, and it has evolved since then. And you can see that the solar panel design of this spacecraft is a bit different, and it has, you can say, if you know the lander which the NASA sent to the Mars. What was the name? I always forget about the name. That name which starts from I. It looks like that. Means the opening of the solar panels is like that, and it has something related to origami. I mean, yeah, space has something for origami people too, because in rockets and in spacecraft development, when everything is being developed has been developed, you need to pack all those things into fairings, right? So you need some people who are actually expert on packing things up, and origami kind of deals something in that field. So yeah, that's the reason why. So now we can have a look at the rocket, and what is its configuration. So this is the Antares rocket by operated by Northrop Grumman, and it used to be an ICBM, but it has been converted now to a rocket. And it has, you can say that in the first stage it has two Aerojet uh, s- sorry, two Aerojet AJ2662 engines with the independent thrust vectoring, right? And it runs on RP1 and logs. And then we have this 80K Kester 30B solid rocket, which is you can say a solid rocket for the this one. This is the second stage. Sorry, this is the second stage, and it is a solid rocket booster. I mean, the second stage is the solid rocket one. So that's why it certainly needs a third stage, right? But Cygnus has its own thrusters to compensate any of the change in the orbit, and that's why it does not have that in this one. So for this thing, for today's mission, we only have it as a two-stage configuration, although the third stage is there, but we don't have it today. And if you want go into a bit depth of it, so it has, you can see that RD-181 engine operated in kerosene and logs here, right? And the second one is 30XL solid rocket motor. And then the third stage is a bit you can say changeable, as in it has like three designs for the third stage. I mean, it is not using today, but it, when it has to use, it can use three designs: this orbital star third stage, the orbital orbit adjust module third stage, and then optional Orion 38 based third stage. Orion is also can be used in this, and the payload capacity for this is around 8 tons to low earth orbit. And yeah, I think that is pretty much about it, right? Yeah. Hi everyone, it's very windy at Wallops Island today. Do you think they can actually launch today? I mean, the wind are in, you can say, in check right now, and wind is not looking a hell lot of a problem right now. It's like only 25% weather violation today. So, yep, the actual weather conditions are looking pretty good for the launch today, like a Phoenix lander. Yes, Sanjay Agarwal. Is it a Phoenix lander or what? I don't remember that. But yeah, let's just get it into now. What are the signs for this mission? What are the actual signs going into this mission? And you might be wondering, what the hell are seeing this thing? So this is what we call micro 16 experiment, right? So what it does um, it is an experiment that aims to further understand the cause of muscle weakening that astronaut experiences in the microgravity. So you now must be wondering, this snake or worm looking like a thing, how can it teach us how the muscles work? So yeah, in order to figure out if decreased expression of muscle proteins is associated with the muscle weakening, researchers study these worms moving around a microscope slide filled with rubber pillars. So the things which you are right now seeing, these are the rubber pillars. And the use of the rubber pillars is to then researchers can then determine the strength of the worms by how much force they apply to the pillars while moving around. And then the results could also support new therapies targeting age related muscle loss on earth. So it's a you can say a bit complex and a very interesting experiment going into this ISS today. And like might be wondering, how can we like study from it? So the thing which we can get from it is like basically scientists want to understand the in space, are does our muscles work differently, or is it like we are not working as much, that is the cause of the muscle loss, or is there something else associated with zero gravity which we haven't identified? So with this worm, they are trying to figure out that only. So how much force it will apply in 0g and in the earth, and comparing the result, they will get the answer. So yep, that is the thing. So this is the one which is going on. The second one is this one, which we call, just a sec, here you go, real-time protein crystal growth on board the International Space Station. Okay, so this one which you are right now seeing is the protein crystal from uh, uh, what we have on the earth. But this thing will this experiment will offer an opportunity to further study, monitor and optimize the protein crystal growth in microgravity. So this RT protein crystal growth 2 experiment will be studying the growth of the protein crystal in microgravity. And yeah, like how the 0g actually affects the protein growth, and further, since it's a protein crystal, right, so it will actually enable us to understand our own protein growth in 0g. So it is also a very good experiment. Then we have this one which we call as um, protein based artificial retina just a sec, is it that only? No. Is the characterization of the function and stability of bacteria rhodopsin following exposure to a microgravity environment. The investigation evaluates a manufacturing. Okay, so this one is a function and stability of the bacteriodopsin following exposure to a microgravity environment, which means they will be actually testing one bacteria on how it behaves in 0g. And it evaluates a manufacturing system using this bacteria, the light activated protein responsible for the activation of the artificial retina. Okay, this bacteria is a light activated protein that replaces the function of damaged photoreceptor cells in the eye. So it's a good experiment. I mean, I don't actually able to understand most of this because I'm not that kind of a guy, but yeah, if you can understand, please do let me also know. And then we have this sleep monitoring in space with dry EEG heads. Sleep plays a major role, and we also want to know the effects of sleep in space. How does that affect our actually sleeping? So yeah, this might help in that. Then we have the Spaceborne Computer 2, high performance commercial off the shelf computer system on ISS, which means a upgraded version of computer, Spaceborne computer. Which means it will be a radiation hardened computer, a computer which can actually work on space. So this is a version 2 of that, and it will actually, you can say, test their research of developing advanced version of computer, kind of like that only. So what else do we got? We have then the brine processor system demonstrates technology to recover additional water from the urine processor assembly, which we actually want, because if you don't know, guys, in ISS we have a shortage of water because all the water comes on from the earth. Okay, and that's the reason why they recycle everything. uh, the urine is recycled there for drinking water. So yep, that is the thing. And this urine processor assembly will actually be upgraded, which means this brine processor system is a technology demonstration to recover additional water from the urine processor assembly. It is also good, right? Then we have the Artemis Hera on space station. Demonstrates softwares to refine data analysis and operational products for future exploration mission. It modifies the hybrid electronic radiation sensor built to operate as the primary radiation detection system for Orion and certified for flight on Artemis 2. So this stuff will actually be a test for Artemis mission, right? And it will basically test the radiation thingy. I mean, radiation assessor. How does that affect this thing? The investigation provides an opportunity to evaluate its hardware in space radiation environment prior to the Artemis 2 flight, which we actually want. So yep, that is the case. And yeah, that is all we got. And we have the feed, putting on the feed for you. Just a sec. And
mark at 11:36 a.m. Central, 12:36 p.m. Eastern. Looking at some scattered deck and cloud ceilings and monitoring some wind gusts, but overall we're looking at about a 75% favorability margin. We are 75% go for launch today. 351, enable your local launch. Mission Control Houston and the Mission Operations Center in Dulles, Virginia have conducted a preliminary T-minus 2-hour go-no-go poll and are go for launch. They're about to come up on another go poll at the T-minus 30 mark. Enabled and illuminated. RSO. RSO. Northrop Grumman CRS-15 mission is named the SS Katherine Johnson. Northrop Grumman named the CRS-15 after the NASA mathematician, a black woman who time and again broke through the barriers of gender and race. It is a company tradition to name each Cygnus spacecraft after an individual who has played a pivotal role in human spaceflight. Her handwritten calculations were critical to America's success during our first human spaceflight missions. Again, this is February 20th, the 59th anniversary of John Glenn's flight. And when he again became the first American to orbit the Earth, it is a perfect tie to the SS Katherine Johnson. While NASA had used the IBM computers to calculate the complex orbital trajectory, Glenn asked to have Katherine Johnson verify the calculations by hand and would not fly until she gave the go.
wow, this is so cool.
We have teams supporting from all over the United States for today's launch, counting down to 12:36 p.m. Eastern. Over at the Wallops Flight Facility, you're looking at Wallops Range Control Center, counting down and walking us through these next steps over the next 33 minutes to a T0 mark.
And Monarch
On top
Aerospace,
of
to
the
answer
Antares
your
rocket, we
question,
have the Northrop
okay.
Grumman's Mission Operations Center in Dulles, Virginia, monitoring the Cygnus spacecraft on top of that rocket. The teams there are led by Mission Director Zach Dwyer for launch. He'll be handing over to Amy Allison for solar array deployment. And of course, the destination for Cygnus after its day and a half in orbit will be the International Space Station. Mission Control Houston standing by and watching the launch and monitoring the operations of the International Space Station in flight. Flight Director Scott Stover is here in the room and just gave that T-30 go for launch from Mission Control Houston. Visiting Vehicle Officer working with teams in Dulles, Virginia is Jessica Doy.
So, yes.
Now, of course, the primary job for today is watching for the launch and making sure everything is go for launch. But we do have 24/7 hour operations for onboard International Space Station operations. We are in a weekend, but the crew on board is enjoying a day off, a day of cleaning, and some exercise. And of course, they'll be watching today's launch. From left to right, we have the Expedition 64 crew, NASA astronaut Kate Rubins and NASA astronaut Victor Glover, Japan Aerospace Exploration Agency Soichi Noguchi, and then ISS Commander Sergei Ryzhikov. We also have NASA astronauts Mike Hopkins and Shannon Walker, and rounding out at the very right side is Roscosmos cosmonaut Sergei Kudzverchkov. Again, we just came to Mission Control Houston while polling a go for launch at T-30 minutes. Currently tracking no issues with the Antares rocket either. And Mission Operations Center in Dulles, Virginia is also tracking everything is healthy with the Cygnus vehicle on top. Now coming up on 30 minutes to launch.
Exactly. So first of all, I should answer your question. The Northrop Grumman actually is more on satellite development rather than on rocket development, right? And it is like a company which develops spy satellites and high-tech stuff which normal people don't means the normal companies don't develop.
To the International Space Station.
That's the reason.
Wonderful.
Why.
We're getting a look at the pad now, looking at the Antares rocket, billing off some conditioned air. Tell us about this rocket, Antares 230 Plus.
Yeah, so Gary, the Antares 230 Plus vehicle is an upgrade to our previous Antares 230 vehicle, which was under the previous CRS-1 contract. This NG-15 mission marks Northrop Grumman's fourth cargo service under the CRS-2 contract, with NG-12 being our very first Antares 230 Plus mission, which was flown in November of 2019. The differences between the 230 and 230 Plus are the upgrades to the Stage 1 core, which has lighter composite structures and an optimized second stage motor. The upgraded Stage 1 core allows Antares engines to perform at full thrust throughout most of the first stage profile. The 230 Plus vehicle also has a cargo mass flexibility in which the Cygnus mass can be defined with agreed upon constraints, of course, but no later than 24 hours prior to launch. So speaking of cargo, another capability of the Antares 230 Plus rocket is that Antares can perform late load operations by the unique pot-top fairing and specialized ground equipment. If you look closely at Antares, you can see the nose of the rocket, and you'll be able to see the little pop-off that we have there, and that can be removed for the late cargo load. And Antares having the ability to do a late load cargo load 24 hours before launch, we're able to support critical research experiments for NASA. And with all this talk about cargo, the Antares vehicle is carrying approximately 8,200 pounds of cargo to the space station aboard the Cygnus spacecraft. And we at Northrop Grumman are very proud of our Antares 230 Plus rocket and are dedicated to providing the best value to our customer in support of our critical mission, of their critical missions.
Now, Christina, we're getting some footage from earlier when we were performing that late load capability. This is a good view of that pop-top fairing. From what I
Wow.
understand, Christina, this is
so
near
cool.
max capacity. We're over 8,000 pounds inside Cygnus. Tell me about how Antares is ready to carry such a mass to the International Space Station.
Yes, Gary, you're correct. Cygnus is near max capacity at 8,200 pounds for this mission. The Cygnus team has been preparing the last few years of an upgraded system to not only add more cargo, but also add more capability to the spacecraft itself to support powered payloads. Cygnus has implemented additional communications and telemetry equipment to connect scientists with their experiments throughout the mission from liftoff to arrival at the International Space Station. All of these enhancements point us toward a long-term goal of growing Cygnus capabilities beyond the space station resupply missions. We also see Cygnus as a strong building block and valuable commercial partner for the next generation vehicle that will go to the moon. And Gary, as you mentioned before, Cygnus, we're so happy that we're able to honor Katherine Johnson for this mission and named her for NG-15. You know, as you mentioned before, Katherine Johnson was an amazing NASA mathematician, and she broke many barriers, including race and gender, while working for NASA and delivered critical calculations for a very important mission that happened on this day. I just also want to mention, you know, as a Native American and from the Navajo Nation, Katherine Johnson was an inspiration for me and countless others to pursue degrees in aerospace, in the aerospace industry. So I'm very honored to be part of the Human Exploration Program, and I also hope to inspire others as Katherine Johnson has to reach the stars when setting their goals. So very happy to be here.
Very good. Christina Halona, thank you for joining us. We'll come back to you here shortly to walk us through some of these upcoming milestones we have, including counting down to that launch mark at 12:36 p.m. Eastern, and, of course, walking us through ascent. We're going to go through some of the great cargo on board. This is a nice graphic that shows exactly what's on board Cygnus. We're talking over 8,000 pounds, nearing 8,400 pounds of cargo, including pressurized and unpressurized. You can see just more than 2,400 pounds of that are scientific investigations, and there are quite a number of them. First is the Spaceborne Computer 2. Now, due to a need to prioritize reliability over performance, computing capabilities in space are reduced compared to capabilities on the ground. This can create challenges when transmitting data to and from space. Although relying on ground-based computers is possible for exploration on the moon or to low Earth orbit, the solution will be a little bit more difficult for exploring farther into the solar system. So in 2017, the Spaceborne Computer study ran a high-performance commercial off-the-shelf computer in space with the goal of having the system operate seamlessly for a year. It successfully performed more than 1 trillion calculations per second for 207 days without requiring a reset. The Spaceborne Computer 2 will build on the success of this first study, exploring how off-the-shelf computer systems can advance exploration by processing data significantly faster in space with edge computing and artificial intelligence. This experiment plans to demonstrate that Earth-based data processing of current station science data can instead be performed on the station. Eliminating the need for researchers to send the raw data back to Earth for analysis could speed scientists' time to insight from months to minutes. We'll also have some space worms heading to the International Space Station. Tiny worms could help us determine the cause of muscle weakening that astronauts can experience in microgravity. Astronauts work out for more than 2 hours a day aboard the station to prevent bone and muscle loss caused by living in a microgravity environment during long-duration missions. Thanks to a new device for measuring the muscle strength of tiny C. elegans worms, researchers with the Micro 16 study can test whether decreased expression of muscle proteins is associated with this decreased strength, and these results may support new therapies to combat the effects of age-related muscle loss on Earth. Now, of course, some of these investigations are scientific, and some of them are technology demonstrations meant for exploring farther into the solar system. There's an investigation called AHOS. The International Space Station serves as a testing ground for technologies we plan to use on future Artemis missions to the moon. Now, the AHOS investigation from NASA puts to the test some tools planned for use on the crewed Artemis 2 mission that will orbit the moon. Built as a primary radiation detection system, system for the Orion spacecraft, the Hybrid Electronic Radiator Assessor, or HERA, was modified for operation on the space station. Verifying that HERA can operate without error for 30 days validates the system for crewed Artemis mission operations. A related investigation, ISS HERA, which you're seeing now, flew in 2019 aboard the station. ISS HERA provided data and operational feedback in preparation for the Orion spacecraft's upcoming crewed Artemis 1 mission. Uncrewed Artemis 1 mission. There's also another technology demonstration to upgrade the environmental control and life support systems. This is a system of regenerative life support hardware that provides clean air and water to the space station. The system will get an upgrade thanks to the Exploration ECLSS. That's environmental control and life support system. This is the brine processor assembly. The investigation demonstrates technology to recover additional water from the urine processor assembly using a membrane distillation process. Now, long-duration crewed exploration missions require about 98% water recovery, and there's currently no state-of-the-art technology in brine processing that can help achieve this goal, but this is one step closer. The brine processor assembly plans to close the gap for the urine waste system on the space station.
Wow.
Now, these are all investigations going to the space station. We have another one that's actually going to be deployed shortly after the second stage ignition. NASA, in partnership with Virginia Space, is helping launch 30 ThinSats built by elementary to high school and university students that will deploy from the second stage of Antares once it reaches low Earth orbit. These projects not only deliver scientific data, but also help shape a new generation of scientists and engineers. ThinSats will be released from the second stage shortly after launch and will transmit data for approximately 5 days before deorbiting and burning up upon re-entry into Earth's atmosphere. Again, currently tracking no issues to launch. Antares and Cygnus looking good at the Mid-Atlantic Regional Spaceport on Pad 0A. You're looking at a live shot from Virginia. Now, on top of the scientific investigations and the technology demonstration hardware is some fresh food. The astronauts aboard the International Space Station can be expecting some cherry tomatoes, some apples, and navel oranges. They'll also get some cold stowed cheese, Parmesan, and sharp Wisconsin cheddar.
Yeah, that water recovery is actually very, very important because during the event of radiation burst or a solar flare, actually astronauts tend to go into a water bath because actually water protects astronauts from radiation. So yep, that is why the 98% water recovery is necessary.
Tell us about some of the milestones that Antares has gone through up until this point and will go through to the T0 mark.
Sure, Gary. So approximately 5 hours ago, of course, our amazing launch team arrived at Wallops Island in Dallas, Virginia, and Chandler, Arizona, in preparation for launch. The team at the launch pad will also went through their checks prior to evacuating the site, and then shortly after, we went through our pre-power up verifications right before we power up the Antares vehicle. Once we power up Antares, we run various tests and checks to ensure all is working well on the vehicle prior to doing our propellant loading. The team also gets various weather updates and range updates to ensure weather and range is clear for launch as well. At this point in time, it's about 10:17 a.m. We're just finishing off the tail end of the propellant loading operations. Once this is complete, the team will top off the propellant and we'll do some fuel adjustments. Then we'll do a final go, no-go poll. It's completed, and we'll proceed to the final countdown to launch. And then at approximately 3 minutes prior to launch, you'll hear that the auto sequence was initiated. This is where the Antares internal flight computers take over and commands the vehicle. The auto sequencer then goes through the final steps of prepping the vehicle for launch, and we'll proceed through the final countdown and launch off.
Okay.
And those milestones all coming up here very shortly. Christina, now take us through ascent. From the moment of liftoff, what can we expect to see?
Okay, so Antares will have a stage 1 ignition at T-0, and we'll lift off shortly after. The main engines will burn for approximately 200 seconds, and then we'll go into MECO. And if you hear MECO, it means it stands for main engine cutoff. So once we get to MECO, we'll go into a short coast right before we separate stage 1 from stage 2, which we call the upper stack portion of Antares. We'll continue to coast a little bit longer for about 30 seconds before fairing separation, and then we'll have an internal separation where the stage 2 flies out of the external upper stack. Once that stage 2 is clear of the upper stack, the stage 2 ignites for a 2.5-minute burn that puts Cygnus real close to the orbit that they need to be in, and then we'll coast to ensure everything is stable, and then Cygnus will be released into the desired orbit. After Cygnus is released, we'll go through some comm checks, and then about an hour to an hour and a half later, we'll separate, and Cygnus will release its solar arrays and be on its way to the International Space Station. So, in summary, it takes approximately 9 minutes to get Cygnus into orbit.
That's right, and we'll be providing coverage throughout that time until we have an orbital insertion. At that time, we will break our coverage, but we'll still be here in Mission Control Houston monitoring the solar array deployment. That takes place a few hours later, and confirm that over some of our social media sites and our blog. Make sure it is receiving enough power. Now, it's going to spend, Cygnus will spend about a day and a half in orbit, catching up with the International Space Station. It's scheduled to be captured by the robotic arm of the International Space Station at 4:40 a.m. Eastern Time, 3:40 a.m. Central Time on Monday, February 2nd. The robotic arm operators on board the International Space Station will be JAXA astronaut Soichi Noguchi. NASA astronaut Mike Hopkins will be backing him up from inside the cupola.
Okay.
For that coverage, we'll be starting.
So he actually meant February 22nd. I think so. Not February 2nd.
Again, that capture time 3:40 a.m. Central, 4:40 a.m. Eastern.
So, hi everyone, hi Tech AK and hi Emily Hurst. You were planning to go to see this launch, but cancel launch after the ice storm hit Virginia. Oh, stay safe, please, guys.
Several visiting vehicles to be attached to the International Space Station after it is captured by Soichi Noguchi. Robotic operators on the ground will take control of the robotic arm and affix it to the Unity module on the nadir side. You can see there, sort of at the center of this configuration of the International Space Station, there are two crewed vehicles aboard. You see on the left the Crew 1 Dragon that carried the NASA SpaceX Crew 1 mission and the 4 astronauts aboard to the International Space Station, and the Soyuz MS-17 carrying Kate Rubins and the 2 Russian cosmonauts to the International Space Station. And, of course, the Progress vehicles currently attached 77, which just arrived earlier this week on Sunday, and on Progress 75 attached to the aft end of the International Space Station.
Countdown 1. Fuel Core 1. Step 385. Fuel adjustment is not required.
Copy 385. Prop 2, configure OCCS for no adjustment to fuel level.
And in work.
And thank you so much, Monarch
LC Prop
Aerospace.
2, OCCS configured for no adjustment to fuel level.
Copy that. Check 386.
For that, and I appreciate
And
that.
admin 387 is not required.
Now listen into the mission control. Then I'll talk.
And launch team be advised 388 is not required.
This is Mission Control Houston coming up inside 15 minutes, counting down to 14. We're still tracking our launch at the opening of the 5-minute window, 12:36 and 49 seconds p.m. Eastern Time over in Virginia, 11:36 a.m. Central Time here in Houston.
Oh, sure.
Again, everything is still looking good. As Christina Helona described, they're topping off some of the fuel in the Antares rocket already loaded with that liquid fuel, RP-1 kerosene, and liquid oxygen, billowing off some of the conditioned air into the 32-degree Fahrenheit weather out there at Virginia. Still at about 75% favorability for launch today.
It will dock tomorrow. Yes, and guys, yep, my talking is a bit less today. This is because we have so much of information flowing in from their end. That is so good. And uh, yes, Angel, we are going in for some nanosats also. For
LC, this is CMD. Cygnus is in launch mode and nominal. Copy that, CMD.
Okay, that is good. Weather is looking good. We are 75% of favorable weather, which means 25% of violation only, which is really good. And this rocket was used to be an ICBM. So I
And
don't
launch
know.
team LC countdown 1. At this time, on a poll to proceed with final countdown. GSO? GSO, go.
Okay.
RSO? RSOs, go. TD? TDs, go. Prop lead?
Prop leads go.
Stage 1?
LC, stage 1 is go. Helium topping is ongoing.
Copy that. Core 1?
In honor of Alexander Diktarov, the late Director General of the Yuzhnoye Design Office, whose efforts in international spaceflight have contributed to the success of Antares, Core 1 is go.
Copy Core 1. MES 1? MES is go. GC? GC is go. And ACE? ACE is go. Mars? Mars is go. CMD? CMD is go. LD? LD is go. NG?
Northrop Grumman is proud to honor NASA mathematician and space visionary Katherine Johnson, whose computational brilliance and relentless pursuit of excellence set the standard for 60 years of NASA mission success. Katherine humbly yet forcefully broke the barriers of gender and race to enable the future of human space exploration and in the process inspire generations. On this anniversary of John Glenn's historic Friendship 7 flight, which would not have been possible without Katherine's calculations, Northrop Grumman and the SS Katherine Johnson are go for launch.
Copy, NG. Launch team is go to proceed with final countdown. Check 393.
Okay, so we are looking in a go
Coming
for
up
the
on
launch.
11 minutes to launch. You just heard that poll. We are go for launch. Again, continuing to watch that weather, but targeting still the opening of our 5-minute window at 12:36 and 49 seconds p.m. Eastern Time. Christina Halona, if you're still with us, hearing some of the words coming from the Mission Operations Center and all the teams working so hard on this mission, tell me about some of your thoughts as we're coming up on inside 10 minutes to launch.
Hi, Gary. Yeah, so our teams spread out all across the United States in Wallops, Dulles, and Chandler. The entire team is, in these final moments, are looking at our various telemetry data to make sure the health and status of the vehicle are within constraints. As you just heard, there was a no-go poll of our Antares chief engineers, safety officers, and leaders to continue the countdown. And we'll continue to monitor the telemetry stream and make sure Antares is healthy and ready to go for launch here in a few minutes.
And we're coming up on that shortly. Vehicle systems look healthy, and we're still 75% favorable. And again, we're targeting the beginning of that 5-minute window. So now that we've conducted that final go no go at the T-minus 10-minute mark, we'll be counting down to about T-minus 5. Antares will switch to internal power at that time, and just a little more than 3 minutes will be the auto sequence handoff to terminal count. The computers will take over for the final steps to get us to launch at the opening of that window.
Ops 1, ACS VDMs, internal power on.
Actually, guys, this 5-minute window is necessary because at this point of time, the ISS will be overhead at this position, which is actually required.
Check steps 396 and 397.
And now just wait and relax and just see this beauty fly to the sky and finally to the International Space Station with the Cygnus spacecraft carrying the science and the supplies to International Space Station, as well as some nanosats which will be deployed afterwards. And I was very impressed with the top of fairing of this rocket. I mean, it's a late load capacity. Like you can just pop off the fairing if you forgot to put in something, and then put in the required payload. I mean, you can't forget obviously, but if some procedure requires a late loading, so that is possible with this spacecraft, with this rocket, and that's what makes it unique, I think so. So hi Dave, hi Angel, hi Danny. What is the red blimp looking thingy floating to the left of the view? I would have to see that again. Whenever it comes, I'll let you know. Next launch is Starlink.
Minus 8 minutes.
Minus 8 minutes.
LC site control GN2 conditioning initiated. Copy site control, check 399.
Venting is occurring right now. Completely nominal. Clearing of the vents. Could be lab red wind, maybe it could be wind, but from the sound it looks like it's venting, but we can't see much of that.
Inside 7.5 minutes, you're hearing some of those countdown milestones. Internal power has been activated. It'll be switched here shortly for the Antares vehicle. The International Space Station is currently flying 262 statute miles over the middle of the Atlantic Ocean, just east off the coast of Brazil.
Weather is looking good, and actually for ICBMs weather is not at all a problem. I mean, weather is a very least of their problem. ICBMs are designed to handle any weather possible, right? So this was ICBM which was made into the rocket, so weather constraint are not very hard.
Copy that lead, check 400, Ops 2, 401, initialize ground ordnance power supplies.
LC Ops 2, ground ordnance power supplies initialized.
Roger that.
Like 1 confirms, ground ordnance power supplies nominal.
Copy like 1, check 402.
And that something looked like that red blimp kind of a thing. That actually was something. We can now see
6 minutes.
Some venting. I think the sound is from venting only. Maybe the pipes are being cleared.
Now inside 6 minutes to launch. Again, targeting the beginning of the 5-minute launch window at 12:36 p.m. Eastern Time. Christina Helona, as we enter these final minutes up until launch, any final words before we let you go and follow the operations for launch today?
No, I'm just thankful to be here, and I appreciate the invite, and I'm looking forward to successful launch. Go Antares.
Okay. Look like there is a problem from NASA's end. So where is it? There. So we are even. Yup.
Ops 2, LC, step 404, you go to initiate engine priming at T-minus 5 minutes.
LC Ops 2, engine priming started.
And Ops 1, transfer avionics to internal power.
Avionics, internal power on. External power off.
So here we go, guys.
Now inside 5 minutes to launch, Antares is now switched to internal power. Christina Helona, thanks for joining us today. But of course, she's going to be busy over these next critical milestones here. Now that we're inside 5 minutes and switched to internal power, the next major milestone is coming up just a little over 3 minutes. We'll begin the auto sequence handoff to terminal count. The computers will take over, and Antares will be counting down with those computers automatically to launch, targeting again 12:36 and 49 seconds p.m. Eastern Time.
Exactly. So hold in tight and watch this beauty fly to the sky, carrying the Cygnus spacecraft, which will eventually go to the ISS, carrying more science, research, and supplies for the astronauts.
LC priming verified.
Roger that.
Okay.
MES-1, we'll check 412.
It may be a little bit windy out there, but since this was ICBM, used to be an ICBM, weather is least of a concern for it. It's
And
a
we're
very
now in
hard
terminal
rocket.
count. Phase 3 dynamic limit will be active at T-minus 3 minutes.
Wind speed, I don't know, but
3 minutes and 15 seconds until launch. Terminal count targeting that exact liftoff time, 12:36 and 49 seconds. Tanks will be pressurized at about T-minus 40 seconds, and we'll be counting down to T0. Everything's good for launch today.
so we are coming in.
Start. Podium bus voltages and currents and nominal.
Copy all, LAC 1. GNC-1, step 418, verify ready for nav mode.
LC GNC-1, orb nav, ready for nav.
And Ops 2, you go to switch to nav.
LC Ops 2, switch to nav.
Orb nav telemetry verified.
Copy all. Check 419 and check 420. TLM, you can switch link 41 to open loop.
LCTM copy.
And
Link
if you
41
have
open.
questions, you can ask me right now, because this is the time, and then we will actually see the rocket launch. It's just 2 minutes and 15 seconds until they light this candle. I'm really excited for this launch, because we actually really don't get these launches from Northrop
2
Grumman.
minutes on my mark. Mark.
There you go. This is a rocket named as Antares, and produced or developed by Northrop Grumman, and yeah, it's designed for low cost access to space. Payload capacity 8 tons, and now it is carrying CRS, commercial resupply mission, to the ISS, which is you can say the most in mass which is being carried to the International Space Station today.
T-minus 1 minute, 30 seconds.
Hold in tight. I think the vehicle is pressurized now. T-minus.
T-minus 1 minute on my mark.
T-minus 1 minute. It's happening, guys. Sit tight. Hold your breath and enjoy the party now. I am really excited for it. Let's just watch those two engines light up to its full power and propel this rocket out into the sky. Wow. That's a
T-minus
beautiful
30
launch.
seconds.
T-minus 30 seconds. Heartbeat is increasing. This is looking very good. We don't seem to have any problem with the weather, and let's hope everything goes well with the rocket. T-minus 10.
T-minus 10.
Okay. 6, 5,
5,
4, 3.
3, 2, 1. We have engine ignition.
Ignition. Whoa.
Main engine start.
And liftoff.
And we have liftoff up in Antares for the NG-15 mission. The Wallops flight facility.
Wow.
Engines are at 100%. Attitude, core pressures, and vehicle subsystems are nominal.
Did you see the winds, guys?
ISS Katherine Johnson takes flight on this, the 59th anniversary of John Glenn's Mercury flight, carrying 8,000 pounds of cargo to the International Space Station. Good performance on the first stage so far.
It goes brrr.
Engines at 100%. All systems nominal.
Wow. This rocket is
Stage 1
beautiful.
continues nominal performance. Engines at 100%. Good core pressures.
Good core pressures. We should be heading in for the max Q now.
Engines remain steady. Attitude nominal.
Wow.
Max Q. Attitude nominal.
First stage passing through the area of maximum dynamic pressure on the rocket.
Is that pressure
90 seconds into the flight.
Which actually means the maximum pressure which the rocket experiences, and if the
This
rocket...
first stage burns for a little over 3 minutes, 3 minutes 18 seconds until main engine cutoff.
The rocket passes that, the rocket is structurally stable, and see the plumes. This rocket has the most beautiful plume.
Stage 1 burnout.
This is looking... wow.
Attitude nominal. Engines at 100% and steady.
MECO coming up now.
T plus 2 minutes. All subsystems continue in nominal performance.
Yep. Wow. I hope we had the onboard cameras. That would have been so good, but yeah, this rocket is beautiful. I mean, the plumes are really beautiful.
All subsystems are nominal. We'll be ready to shift down to 80% on the engines at 170. Startup slow throttle down.
Throttling down at 3 minutes into the flight, main engine cutoff coming soon.
No, Rihan, that does not mean that maximum
Throttle
pressure.
down to 55%.
Okay, we should now be seeing the MECO. And I think it is MECO.
Main engine cutoff.
We have MECO. Antares entering into a coast stage. Fairing separation will occur about 30 seconds later. As we lose sight of the vehicle, now switching to animation. Some controlled firings on the interstage of the rocket.
Attitude nominal. Good separation.
And then now this stage is the solid rocket one.
20 seconds to stage 2 ignition.
Which needs to happen. And you can see the altitude right now. We are already...
All subsystems nominal.
100 kilometers up. Wow.
Fairing separation. Interstage separation.
Confirmed fairing separation and interstage.
And there you go. We have the solid rocket
Stage
booster
2 ignition.
So,
Stage 2 ignition confirmed. Stage 2 is a solid rocket motor, burns for about 2 minutes 44 seconds.
And from the trajectory only and the altitude which it has achieved, we can see that it actually has a very steep trajectory.
Stage 2 will continue to burn for another approximately 2 minutes.
And which makes sense also, because this SRB produces a lot more thrust.
Altitude 138 kilometers.
So here you have the velocity, which is going in the 4.6 kilometers per second right now. The altitude is 146 kilometers. Apogee, we can see that it's 165, 166.
Mission time 300 seconds. Velocity 4.8 kilometers per second. Altitude 150 kilometers. All systems continue to perform nominally.
And the perigee...
Good calls. 5 minutes 15 seconds into today's flight.
Perigee should come out of the Earth. It's right now in minus, which means the lowest point of the orbit is on the Earth.
Stage 2 motor pressure, nominal.
And apogee is the highest point on the orbit, so it is increasing. And yeah, it should continue to increase, and the perigee also, which will come out of the... when it will come out of the Earth, the lowest point in the orbit, then the minus sign will go away. And it should come like about 100 kilometers above the surface.
Altitude is 170 kilometers, roughly 1 minute to stage 2 burnout.
This is so cool. I mean, these readings...
All stage 2 and GNC parameters continue to be nominal.
Are really good.
6 minutes 15 seconds into the flight, coming up on stage 2 burnout of that solid rocket motor. That'll initiate a 2-minute coast period until second stage separation.
So we are looking in, apogee should be coming in.
Stage 2 starting to tail off.
And we can see some RCS burns also to keep it pointing in the right directions. That blue
Roughly
spikes are
15
that.
seconds to burn out.
RCS are the thrusters, which is keeping in the desired direction. We have the burnout.
Stage 2 burnout. Attitude nominal.
Stage 2 burnout, good attitude. We're in a coast period now.
But still the apogee is increasing somehow. I mean, we do have some residual
Cygnus
burns
exposed after that fairing separation, and will continue to carry the second stage with it until about 9 minutes into the flight.
This should not happen, right? The apogee should not increase. I mean, it's not in acceleration. And nothing is happening to perigee. Okay. Now it's stable. I mean,
attitude nominal. Expected attitude control system thruster firings received. Continuing on course.
Okay. Actually, the thing with SRB is that it has some residual burn. After burnout, it has some residual thrust. Not very much, but still it has. So might be interfering
Roughly
with
1 minute to payload separation. Altitude 185 kilometers. Velocity 7.5 kilometers per second.
We can see the velocity is 7.5 kilometers per
All systems
second.
continue to operate as expected.
This is so good. I mean, around 17 times faster than a bullet right now. If I'm not wrong.
Approximately 30 seconds to spacecraft separation. Attitude nominal. Systems continue to perform as expected. Attitude corrections maintaining expectations.
Okay, looking good. And
LCGSO, I just released red team to the pad.
Copy that.
Spacecraft separation.
And we have the spacecraft
Confirmed.
separation.
9 minutes into today's flight, Cygnus has separated from the second stage.
LC Ace, that concludes our callouts.
Copy that, Ace. Okay, NG-15, excellent job today. Let's go ahead and wrap up through this post-launch checklist. And Prop 1, can you report on status of pulse purging?
Pulse purging has just started.
Copy that. We'll check 430.
And there you go, guys. We have a successful launch to the International Space Station right now.
And GNC-1LC,
we don't have, I mean, right now it is not going to the ISS, but still it is on the way to the ISS.
Emailed, confirmed. Give me a call back on step 431.
Copy and work.
From the Wallops Range Control Center in Wallops Island, Virginia, some celebratory fist bumps as they successfully delivered Cygnus into orbit, a 9-minute flight on top of Antares from Virginia Space's Mid-Atlantic Regional Spaceport into orbit. Cygnus now flying free. The SS Katherine Johnson in flight will make its 1.5-day journey, just a little shy of 2 days, to the International Space Station, arriving in the wee hours early morning on Monday, February 22nd.
Arm enable rotated, arm enable indication no longer illuminated.
Copy that, Ops 1. And Ops 1, disable your local launch enable button.
Ops 1, launch enable removed.
Okay,
flight
so
controllers in Dulles, Virginia, Northrop Grumman's Mission Operations Center will take control of the Cygnus and monitor its approach to the International Space Station over the next couple of days. Solar array deployment coming in a couple of hours. Will be breaking before that, and we'll provide confirmation of that via our blog and social media. Before we depart with you today for our coverage of the launch of Northrop Grumman's CRS-15 mission to the International Space Station, we're bringing on Deputy Manager of the International Space Station Program, Kenny Todd, on with us to provide some remarks. Kenny, thank you for joining us today.
Hey, Gary. Good morning. It's good to be with you.
Kenny, this launch comes ahead of a crew rotation and, of course, in the nearer term, some EVAs. From the perspective of the International Space Station program, what is the significance of this mission, CRS-15?
Well, Gary, I mean, this particular mission has about 8,000 pounds of cargo coming to the space station, and roughly a third of it is going to be dedicated directly to utilization and science on board the station. And so, again, that's our bread and butter. That's what we're up there to do is really do the utilization and science that our commercial customers need, the things that we need to learn in order to go further into our solar system, our human research. And so we've got a lot of this flight that's dedicated to that kind of activity. In addition to that, we've got a little over a third of it that's dedicated just to basic vehicle systems maintenance hardware and some new technology that we're bringing on board. So again, as we look to go further away from low Earth orbit, the thing that we have to do is continue to learn, about the systems that we're going to need, and the ISS provides a great platform for that. So we are launching some new hardware in the vehicle systems area that allow us to demonstrate some of this technology and ensure that it'll be there for us when we need it in the future. But then, as always, these Cygnus flights are very important to us because they bring up a lot of crew supplies as well. They are a workhorse when it comes to making sure that we keep our crews sustained on orbit with the different consumables that they need. So, again, a very important flight for us, and we're glad to see it off the ground and on the way to station.
Off the ground and on the way to station on time, Kenny. This is coming right on the heels of Texas having some severe winter weather. Now, how were International Space Station operations continuously supported during those rolling blackouts across the state?
Well, there's kind of two facets to that, Gary. There's the facilities. The facilities themselves are from a power standpoint, we're fairly redundant. We have generators here on site in MCC, but we also have control centers around the world, Gary, that we can leverage into whenever any one of us has a particular issue going on at their site. And so, when you have a program like the space station that's been around 20 plus years, I don't want to say we've seen it all, but we most definitely have had our challenges through the years when it comes to supporting. So one facet is the facilities, and we're in really good shape there. The other facet is just our people and making sure that we have the people available to come in and work and make sure that we're keeping an eye on our friends and colleagues up in low Earth orbit and having their back. And I think the team has done a really nice job here again because we're very well practiced living here on the Gulf Coast. We're pretty well practiced at contingency operations and knowing how to staff the facilities and make sure at the same time that we're taking care of our people and their families.
Hey, that's right. And the crew is going to be expecting all this 8,000 pounds of cargo here in the next couple of days. Tell us what's ahead for once Cygnus arrives in terms of capture, cargo operations, and some of the science on board.
Sure. We talk a lot of times around here in terms of dominoes, and we have a lot of dominoes stacked up right now. When you look into February and the early part of March, getting the vehicle to station, getting the Cygnus there is that first domino, and with that, we'll get the hatch open here. On the day that it arrives, we got some key science objectives that we want to get going in that first couple of days. So the first 2 or 3 days after it gets there, we'll be heavily intensely focused on the science that we need to get up and running. Then shortly after that, merely 4 or 5 days after that, we'll be heavy into doing a set of EVA preps. We're at this point planning on going out to do an EVA in the possibly as early as next weekend. We've got a double EVA planned, and so we'll get busy on that as quick as we get the Cygnus, get the science up and going that came up in Cygnus, and then we'll be on to doing EVAs.
A lot coming up here in the near term. Kenny Todd, thank you so much for joining us here at the end of our launch coverage.
Thanks for having me, Gary. I appreciate it.
Again, we had a successful launch of Northrop Grumman's CRS-15 mission on time today, 12:36 and 49 seconds p.m. Eastern Time. You're getting a live look at the Mission Operations Center in Dulles, Virginia. Northrop Grumman flight controllers taking control of the vehicle and will monitor its approach to the International Space Station over the next near 2 days until it arrives in the early morning of February 22nd, Monday morning. Robotic operators Suichi Noguchi and Mike Hopkins aboard the International Space Station will be poised at the controls of the Canadarm2, the robotic arm of the station, ready to capture it when it arrives Monday morning.
Okay.
The Cygnus is in orbit right now, but its solar arrays are not deployed. We will be wrapping up our coverage and providing confirmation of that solar array deployment here in the next couple of hours, and that it is receiving power and well on its way to make that journey to the International Space Station. Our coverage on Monday morning will begin at 2 a.m. Central Time, 3 a.m. Eastern, to monitor the approach and
to what we have it here, guys. Okay, now I can finally talk, right? We have a beautiful launch. I mean, the launch which we had was a remarkable one, I should say that. I mean, the handling, how it handled the wind there. Literally, it just was, I mean, did you see that horizontal movement when it was just moving up? It seriously deviated from its path a bit just because of the wind. That means the wind was really high at that time, and the rocket actually handled it perfectly well. I remember that this kind of wind handling I just saw in one of the rocket lab launches of the Electron. That was I remember that, and Rocket Lab's Electron rocket is also very capable of handling winds, and we saw that here also with the Northrop. So yep, we had a beautiful liftoff of that blazing two RD-181 engines powering the rocket up to the sky, carrying this Cygnus spacecraft, which you can see right now, and it will it is right now in the orbit, and in just 2 days or so it will rendezvous with the International Space Station, and then it will be birthed, or you can say it will actually be birthed to the International Space Station rather than docked. This is a Canadarm, which you can see right now here in the image also, that will catch it from the space. This arm, this is the Canadarm robotic arm which they have, which the if you remember, the Cargo Dragon version 1 of SpaceX were also used birthed with this technique. So yep, here we have with this, and the solar panels are always unique for this spacecraft, which I really love in this spacecraft. That's why it is one of my favorite and beautiful looking one. So yeah, this launch has actually broken some records of how much mass it can carry. The payloads have carried to the International Space Station. This is the highest one in CRS-1. I mean, the CRS mission. If you can compare the tally of the CRS mission, the commercial resupply mission, this is the mission which carried the most of the mass. So yep, that is the case. And hi, thank you so much for Mandar Mastery for that appreciation. Appreciate that. What is the difference between the oxygen making machine on ISS and other one with the Perseverance? Rihan asked. So the difference between the oxygen making machine on the ISS, I mean, there is a hell lot of a difference. I mean, on Mars we have MOXIE, which is on Perseverance rover, and the role of it is to convert the CO2 from the atmosphere into oxygen and carbon monoxide. So what it will do is it will capture CO2, then electrolyze it, and then produce carbon monoxide and oxygen atoms, and then those oxygen atoms will combine in the electrode to form oxygen molecules, and yeah, that's how they will get that from. But on International Space Station, mostly the formation of oxygen is relied on water. They electrolyze the water, and those water gets electrolyzed and broken down to hydrogen and oxygen, and those oxygen is used most of the time. So they also have some CO2 scrubbers, which is also very necessary. People usually forget about the importance of CO2 scrubbers because we know that we need oxygen to survive, but we also need that CO2 to be eliminated from the atmosphere from a certain level, because otherwise it will create a problem for us. I mean, CO2 is a byproduct which our body does not like. That's why it excretes that, and too much of it will obviously be a problem, and that's why we have what we call CO2 scrubbers also installed on the space station. So yeah, that must explain the difference between those. Um that was a beautiful launch. Hey, has anybody heard anything regarding the SpaceX SN10 flight test going to happen? Also, is Starlink back on the track for its launches? So the Virginia asked this question, and to answer that, first of all, the SpaceX SN10, they are in the role. Most probably, we must be having the static fire by tomorrow, means the Monday, if I'm not wrong, and yeah, 23rd Feb. Yep, that is the case. So Monday or Tuesday we will be having the static fires, and after the static fire is done, then we can expect some flight test of the SN10. So maybe by the end of February we will get the flight test for the SN10. And talking about the Starlink launches, so this Starlink launches will get some, I mean, will get some penalty for now. I mean, SpaceX is right now grounded for whatever happened with those booster. Okay, so first of all, thank you so much, Octagrabber, for that €5 super chat. Thanks for your coverage and enthusiasm. Hashtag Space Tubers. He says, thank you so much for that. It really helps the channel to stay alive and get this coverage to for all of you guys. Really helps it. Thank you so much. And if you want to support the channel, you can do that by becoming a Patreon or one-time funding. So really appreciate that. Thank you so much, Octagrabber. And what was I saying? The Starlink launch. Okay, so I remember one more thing. Let me just have it up for you. Do you remember the seagulls from the SpaceX launch? Do you remember that? I mean, the drone ship, they were on the drone ship, right? You remember that? They look like this now. We have this NASA spaceflight fleet cam, and we can see that we do have some seagulls, 3 seagulls on the, of course, I still love you drone ship, or 1, 2, and 3 already present. I mean, these 3 seagulls were there, and that's why Falcon 9 decided to divert from its course, right, to save him. And now these seagulls have acquired this drone ship as their own, and they haven't moved. I mean, obviously they must not be the same which we had on the landing time, but I will be really surprised if if that's the case. So yeah, here you go. We have this image for you, this video coming out from that craft. Okay, so just because what happened with the Starlink launch, the booster was unable to land. The SpaceX is right now grounded. As in, they have to analyze what actually went wrong and how they can correct it. Once they have a solution, then they will be able to fly another launches. Although the primary launch of delivering the satellites to the orbit was very much successful, and yes, that's what we want, right? So that was pretty much successful, and the only the booster landing part was a bit odd. And people actually, the if you haven't seen, actually let me just pull up that for you only to see what am I trying to say. Just a sec. So these seagulls have actually declared that territory on this drone ship. That is good. So let me just tell you what I actually got from that Starlink mission. if I can have it up for you guys. I have a couple of things to say for that. I mean, you must be knowing it already. So this was the landing burn, sorry, the entry burn which the SpaceX was doing with the booster. And then what happened is you can see that, just a sec. Yep. We got a confirmation of entry burn cutout, but then also okay, right now it is burning and we have a cutoff now. But then also we could see something right here. First of all, we had some analysis from Scott Manley also that he was able to identify that booster actually didn't slow down enough, okay, for the entry burn to be successful. I mean, he compared the burns from the previous mission and this one, and this we saw he saw that uh, this entry burn was not very much efficient in slowing down the vehicle. So there was certainly a problem with the engines, and here you can see some sparks coming out of after the burn was completed, and these are the sparks which is coming out mostly from the engines, if I'm not wrong, because these are not the sparks which comes when the engine is burning. This bluish sparks does not say that, okay. And we could also see the sparks, actually the sparks, these are the sparks coming out, right? And this happens when it is going too fast in the atmosphere. So yep, it was going in too fast, as well as there was some problem with the engines, both of them combined, and we get this. So after that we lost the telemetry also. We were actually, see, we lost the telemetry here, and yep, that happened. So after that, what we got during the landing, let me just switch over to the part where we have the landing. So the vehicle telemetry is lost since the vehicle is autonomous already, so it has it's programmed to light up the engine, right? So that's why it will be lighting up soon. So let's just, and here you go. So from here, first of all, look at these three seagulls which you just saw on the when this drone ship returned to the port. These three seagulls were already there, and about what happened during the landing burn, we can see the flash here. We can see some flash which is orangish in color, right? See here. And that is not the case when the vehicle is burning, the means the engine is burning to its full power, and it is burning as intended. When it is burning as intended, the flash is mostly white, and it was, you can see that it was not white but certainly orange, which say that it was having some issues with it. So yep, that's the case. Here that was a simple analysis, and these three girls have actually uh, conquered it, and we have this thing here, right? Thank you so much, Angel, for that €1 super chat. Really appreciate it. And okay, so what do we have now here? Depends, bad weather in Texas. Okay, no video feed from the Antares, only animation. Yep. And I was planning to have some KSP one, but right now I'm going into busy um, from my personal work. So that's the reason you didn't get KSP for this particular launch, because I actually intended to get one. So yeah, that is the thing. They all the drop in the ocean, no one goes to space. No, that is not the case, Sergi. How many here? Okay. Eagles have the best seat in the house. Lab Redka actually, yeah, concludes that all. So if you have any other questions, you can ask me, and we will be getting in some images and the videos from the Mars round. Okay, let's just talk about that for a bit. Let me have that here. We also had actually the image, the first image of the Mars, right? me have it for you. I mean, the first images as well as the image which was captured by the camera and during its sky crane maneuver. Here you go. This is the image. And it is a very high quality one. See this one now. Here you go. If you have missed this image, I really recommend you to see this, and here I'm showing it also, so you can see that this is the image taken by the camera, mostly the TRN camera, which took the high frame rate and high quality images, which we actually can see now, and it is looking so beautiful. Literally, I mean, you can see Percy being you can say being ready for the touchdown, and now it's attached to the threads right now because the sky crane was doing its maneuver, right? And it was this image, I mean, made my day. And now in just an hour from now, NASA will officially will be releasing some images and the videos and the sound also, sound of Mars. Okay, so people are actually spreading some fake news right now with some footage from the Curiosity rover, and some sound also associated with it. That is not true. NASA hasn't released anything, and that video which you have seen, if I can pull that for you, um that is that, I don't know if I am be able to know or not, but that is not true. Right now NASA hasn't released anything, and that footage was from Curiosity rover. Video footage is actual, but it was from Curiosity. Sound is not. So yeah, this is the descent and the first color images from the Mars. You can see these are the images from Perseverance, and these are its tires, which we can actually see that it is different from Curiosity. It has less threads, and are more capable one, because Curiosity tires were actually damaged, okay, during its lifetime, so they upgraded the tires for this one, and yeah, this will help them. So yep, that is the case. You have questions, you can surely ask me. Can you give me the name of the Indian rover which was going to launch on moon as a part of NASA program? What is the recent update on it? Dian asks, Indian rover which was going to launch on moon as a part of NASA program. I don't think so. We have that thing right now, but name rover. Okay, so the rover name is Pragyan Labrat, and the lander was Vikram, and that was not launched by NASA. That has nothing to do with the NASA. If you are confused by the other company, I mean, I know what you are talking about, but it was actually not supposed to be launched by NASA, and I know what you are talking about. You are talking about Team Indus, if I'm not wrong. There is one company called Team Indus which actually participated in Google X Prize, and it was supposed to launch its rover there, and they had faced some problems here sustaining their business, and then it was acquired by a company in US. I mean, if you are talking about that, and that is right, kind of associated with some moon missions right now, but it is nowhere launching right now. But yeah, that is the case. But if you are talking about the Chandrayaan 2 mission, it had this orbiter Vikram and the orbiter, the Vikram lander, and the rover named Pragyan. Orbiter is well healthy and doing its business right now. I mean, generating science in the data. But the Vikram lander had some issues during the landing part, and we don't have any official word from actually what happened uh, during that descent part, but we do have some speculations that I mean, they were talking about hardening the legs of next mission, as well as reducing the number of engines. So you see, and we also saw that from in the official coverage also, that it was flipping, spinning and flipping, rotating and whatnot. So maybe one of the engine actually didn't work as intended, and maybe shut down, and which caused torque in the rover, the lander, and it basically spins. So yeah, that is the thing. What was the maximum temperature the equipment experienced? Which one? Mike Bronkala asked, but which equipment are you talking about? If you are talking about this Percy rover, it had the heat shield, right? And it didn't enter the Mars orbit. It just come blazing into the Mars atmosphere at escape velocity. And the temperature which the heat shield experienced was up to 1300 degrees Celsius. So Team Indus rover, no. That is not the case. I don't think so. I'm talking about Team Indus rover. Okay, man. So you that must answer your question. That Team Indus project has been acquired by some US company right now. I don't exactly remember the name. So maybe it will be soon be. I mean, I don't have much update about it. So whenever I have, I will surely tell you what is the. Mm. And if you have any other questions, you can ask me right now, or else we can just end this stream and wait for the official things to come. I mean, the images to come from NASA with the sound on it. And that is the official one, not the one which you were thinking. And if you guys, do you know that there was a camera in Curiosity also? If you don't know, let me just have up for you. The Curiosity descent. Actually, the Curiosity also had this its camera, and it had a low frame rate on it, obviously, and it only had a camera, but it didn't do anything proper. But yeah, it had a camera, so we have the images. So have a look at what Curiosity descent looks like. There were 297 frames captured, and it was a low frame rate one, and yep, we got some images out. You can see right now the heat shield separated. We have right now, I mean, in parachute descent, we are right now, the Curiosity was right now experiencing parachute descent, and right now it is in parachute only. And now I think this crane has taken care of. We can see the plume sitting in, hovering, and deploying the rover down to the surface. And that's what we got. And hopefully for this time, we will be actually getting some high quality and high frame rate images, which I'm really very excited for. Wow. Vikram is on the moon, Angel. I mean, kind of, you can say that. I mean, it landed. I mean, not landed, but it crashed on the moon. So you can say Vikram is on the moon. And it also had some passive experiment, which was actually a laser retro reflector, which was supposed to be just a reflector of the any source, light source, laser source. I mean. It may have survived, but we don't know what happened exactly to the whole rover. We haven't had any confirmation from the ISRO, nothing official yet. But Chandrayaan 3 is coming up. Hopefully by December this year, we will have the Chandrayaan 3, which will only have the lander and the rover. Yep, lab rat. We have some images coming in from the LRO. I am really very much interested for the launch site images from Chandrayaan 2. If you don't know, guys, the Chandrayaan 2 has the highest orbiter image, highest resolution camera right now on the moon, around 0.25 meter per pixel, and it was able. It can be. I mean, it can. It is actually capable of. Knowing exactly what happened to Vikram, but I don't know, maybe what happened. ISRO is reluctant to tell, or maybe there is something I don't know, which is not right now not confirmed or what, but we don't have some confirmation. So yeah, that is the case. So I think we can end the stream, and hopefully let's see what we have in for the curiosity as well as for the perseverance. We know what we had for curiosity. Now we should be waiting for perseverance. In an hour or so we will be getting some images, and don't worry, you will be getting the images for you on this channel. So I'll be uploading it hopefully, and yep, let's see what happens. John Wilson asks, if Perseverance actually did find the life on Mars, what would be the next step? First of all, it will answer the most awaited question which needs to be answered by the humanity. Are we alone on the universe? And that answer would be no right now. Because first of all, the life which it will be find, it will not be an intelligent life, it will be a microbial life, and maybe not even a life but a biosignature that someday, sometime life existed. So yep, that is the case. And yes, Angel, the orbiter is still operative. It has a it was a the science mission duration was for 1 year, but seeing the capability of it, it was extended to 7 years. So yep, that is the case. And after if they find the life on Mars, okay, so first of all, that will be a huge step in discovering and studying Mars, and people will be then really be actually interested in studying this extraterrestrial alien we have, right? And if we actually have something, and if we actually have some biosignature or microbial life, even if right now also present, that could certainly mean that Mars was actually a habitable planet, and something else actually happened. Something actually happened to it, and it didn't survive. So if we are able to identify that and get to that, so that would be a good step for us. Yep, I am active on Twitter. Rihan, you can follow me on Twitter at the @RocketKyan. I am so much active on that on platform only. So if you want some space updates, you can have that. Oh, okay, John. So I think we can sign off now. It was nice. It was a very nice mission, a beautiful mission coming in from Northrop Grumman, carrying the Cygnus spacecraft to the orbit right now, and hopefully to ISS also. And we can get some ton of science out of it. So it was nice talking to you guys and having this coverage hosted. And yeah, thank you so much for all your support. If you like what I do, you can subscribe, and until then, wait for my Percy rover images, and yeah, stay safe, stay healthy, and bye bye.